This video is a vector method of solution for Newton's second law of motion. When we say second law of motion, summation of forces is equal to mass times acceleration. A 1.5 kilogram model helicopter has a velocity of 5 meters per second at time is equal to 0 or initially. It is accelerated at a constant rate of 2 seconds, after which it has a velocity of 6I plus 12J meters per second. What is the magnitude of the resultant force acting on the helicopter together with during this time interval? Now we are given with the following parameters. Okay. The initial velocity at time is equal to 0. VI now is equal to 5J meters per second. VI or VO as a representation of initial velocity. Now for the final velocity after 2 seconds, VF is equal to 6I plus 12J meters per second. Now we are given with the mass of the helicopter at 1.5 kilograms, so it's quite heavy, even it's a model, with a time of 2 seconds. Now we are going to solve for the resultant force F. And if we're going to proceed with our solution, let's solve for the acceleration first. Okay. Now, remember, acceleration is equal to the change in velocity per change in unit time, or this is VF, or final velocity minus initial velocity all over final time all over initial time. Now let's substitute the following given as the following. So the final velocity is 6I plus 12J quantity meters per second minus the initial velocity as 5J meters per second all over our final time at 2 seconds minus the initial time 0 seconds. Now let's simplify the following unknown equation because it has two unknown variables as I and J. Our acceleration is equal to 6I, so 12 minus 5Js gives us plus 7J meters per second per 2 seconds. Okay. Simplifying the following gives us 3I plus 3.5J meters per second squared. Now let's apply Newton's second law of motion statement that force is equal to mass times acceleration. This gives us the following. The mass of helicopter at 1.5 kilograms multiplied with the acceleration 3I plus 3.5J meters per second squared. Or this is, if we're going to distribute the mass 1.5 kilograms with the acceleration, gives us 4.5I plus 5.25J in newtons. Okay. Now remember, if we are given with two unknown variables, the representation of the first one is, wherein our first one is I, this is the X component, and J is the Y component. Thus, this gives us our force Fx is equal to 4.5 newtons, okay? And Fy is 5.25 newtons, okay? In this equation, 4.5I here is the Fx, and 5.25J is Fy. Okay? To solve now the resultant force F now is equal to the square root of the X component of force squared plus the Y component of force squared. Now let's substitute the following values. This gives us the square root of 4.5 newtons squared plus the quantity of 5.25 newtons squared. or simplifying the following gives us 6.91 newtons.